The video will start in 5, 4, 3, 2, 1.
Have you ever wondered if time travel could move beyond the pages of science fiction and become a scientific reality? For generations, the idea of traversing time has captured our imaginations, from classic novels to blockbuster movies. But is there a real scientific basis for time travel? One of the most intriguing possibilities lies in the concept of wormholes, hypothetical tunnels through space-time. Wormholes could connect distant points in the universe and, in theory, allow us to travel through time itself. These cosmic shortcuts are often portrayed in popular culture, from Interstellar to Stargate, as gateways to other dimensions or eras. But are these depictions rooted in any real science? Today, let's explore the fascinating possibility of wormholes and their connection to time travel. To understand this concept, we first need to ask, what exactly are wormholes? A wormhole, also known as an Einstein-Rosen bridge, is a theoretical structure connecting two separate points in space-time. Picture it as a tunnel with two ends, each in different locations, potentially even in different universes. This idea arises from Einstein's theory of general relativity, which describes how massive objects curve space-time. If space-time can be bent enough, it might create a shortcut between two distant regions of the universe. Think of it like folding a piece of paper so 2 points touch, forming a direct connection. Traveling through such a wormhole would allow you to bypass vast stretches of space and perhaps time. But how could wormholes enable time travel? Here's where it gets even more mind-bending. The key lies in the relationship between time and speed, as described by Einstein's relativity. If one end of a wormhole is accelerated to near light speed and then brought back, time dilation would cause it to age differently than the other end. This means the two ends of the wormhole could exist at different points in time. Traveling through such a wormhole wouldn't just take you to another place. It could take you to the past or the future. Time dilation is more than just a theory. It's been confirmed through experiments with high-speed particles and even atomic clocks on fast-moving jets. So, if we could stabilize a wormhole and subject one end to extreme velocities, it could become a literal time machine. But before we start dreaming about time tourism, there are major challenges to overcome. The first challenge is stability. Wormholes are thought to be incredibly unstable. Any matter attempting to pass through could cause them to collapse instantly. To keep a wormhole open, it would require exotic matter with negative energy density. This type of matter, if it exists, would have properties opposite to normal matter, acting like a kind of anti-gravity. While negative energy has been observed in tiny amounts in quantum experiments, we've never found or created it in a usable form. Without it, the dream of stabilizing a wormhole remains out of reach. Then there's the issue of paradoxes. Time travel, especially to the past, brings up the possibility of paradoxes like the famous grandfather paradox. What happens if a time traveler changes the past in a way that prevents their own existence? Or consider the bootstrap paradox, where something is sent back in time and becomes the very cause of its own existence. These paradoxes challenge our understanding of causality, the principle that cause precedes effect. Would wormhole time travel violate causality? Some physicists believe the universe might have safeguards to prevent such violations. Stephen Hawking proposed the chronology protection conjecture, which suggests that the laws of physics could prevent time travel to the past. Even if wormholes are possible, the universe might not allow us to use them for time travel. This brings us to a deeper question. What is the nature of time? Is it a linear progression from past to future, or could it be more flexible, allowing loops and shortcuts? Wormholes force us to rethink our assumptions about time and causality. Despite these challenges, research in theoretical physics continues to explore the possibilities. Some physicists have speculated that wormholes might be connected to quantum entanglement, a phenomenon where particles remain linked across vast distances. If this connection exists, it could provide insights into stabilizing wormholes and even using them for practical purposes. The search for answers pushes the boundaries of our understanding of space-time, relativity, and quantum mechanics.
And thanks for watching.